Let's move on to problem number 13. Problem 13 states the following. For how many different integers n will the expression 6n squared plus 5n plus 4 divided by n also be an integer? Now, this is a fraction. And the question is, when is a fraction an integer? So if you look at fractions like, say, 12 over 5, then this is not an integer. Okay, this is equal to 2, 4. But if you look at 15 over 5, this is certainly an integer. Or otherwise, even 15 over minus 15 over 3 is equal to negative 5. That's an integer. Okay, so a fraction will be an integer provided that the denominator is a factor of the numerator. The numerator could be an integer, but when you factorize it, you can factorize even negative numbers as long as you multiply both the factors are integers. So here minus 15 is 3 times negative 5. So both 3 and negative 5 are integers. So let's go to this problem and ask ourselves how to solve this. So if you look at the given fraction, it's 6n squared plus 5n plus 4 all over n. And you can write this as, because you got the denominator is just a single object, you can write this as 6n squared over n plus 5n over n plus 4 over n. Now, if you simplify this, the same, it's got a common denominator n, and you come back to the same thing. But here now 6n squared over n is 6n, 5n over n is 5. You cannot simplify 4 over n. Now n is an integer, it says here. So therefore 6 times an integer is again an integer. And if you add 5 to an integer, you get integer. So this entire first part is already an integer. You want the whole thing to be an integer. So it will be an integer provided what remains is an integer. Then you can say the sum of two integers is an integer. Now, as we just said now, when is 4 over n is an integer? It is provided n is a factor of 4. Then n over 4 is an integer. Now, what are the factors of 4? And we can say 4 is 1 times 4, or 2 times 2. So it's 1. Yeah, but what about negative 1 times negative 4? Negative 1 times negative 4, both are integers, and the product is 4. So you can have negative. So it could be plus or minus 4. 4 and negative 4 are integers, are factors. 2 and negative 2, and 1 and negative 1. These are the only factors. So the question is, how many different integers will this expression be an integer? So the answer is 6. 2 and 2 and 2 make 6. If you substitute any one of these values, any one of these 6 values, this expression will become an integer. If you wish, you can try it out. Okay, so that takes care of that problem. And so if you look at the solution which I've given you. You can see here at the bottom the answer is 6 values. Okay, let's get on to the next problem. Now the next problem is the following. It says that in a bag, it's problem 14, in a bag that contains 12 balls, there are X white balls. Okay, the probability of drawing a white ball from the bag at random will be P. So let's just see what this means. I could have a bag and it's got white balls. It's got other balls as well. Okay, let's just, here's the white balls. And suppose it's got some other balls. I'll change the color here. Okay, so what is the probability of drawing a white ball? You'll see there are 4 white balls, 4 red balls, so there are 8 altogether. So the probability of drawing a white ball from this will be 4/8. Right? If I had just one ball, the probability will become very much smaller. It will be 1/8. Right? So in this case here, we are told that there are X white balls and there are 12 balls altogether. So what is the probability of drawing a white ball if there are X white balls? And the probability of drawing a white ball sorry for the bad writing. I'm not very good with this pen. So you got X balls inside the bag, and I mean X white balls. There are 12 balls altogether. So therefore the probability, as we saw here, is X/12. And it's given that this probability is P. See, the probability of drawing a white ball is P. Likewise, now the ball is put back into the bag. So the bag now has got 12 balls again. But 6 more white balls are added. So the total number of balls is now 18, right? And the total number of white balls is X, and you added 6 white balls. So this is the probability of the new probability. And yeah, it says the probability of drawing a white ball is 2P. Okay, so now you got 2 equations with 2 unknowns, P and X. And the question is, what is the value of X? The way to do that is to eliminate the P from this. So you can see 2P, this is P, so 2P is that, and that is equal to X plus 6/18. Because it's given the 2P is equal to X plus, 2P is equal to X plus 6/18. Okay, the 2 cancels with this. That X/6 is equal to X plus 6/12. Cross multiply, you get 12X is equal to 6X plus 36. Cross multiply, and then you'll have 6X is equal to 36. If you bring the x's to one side, so therefore x is equal to 6. All right. So the answer to this problem is 6. Let's just check it out. Let me go to the page where um, okay, it seems that I had x over 12 is equal to p, x plus 6 over 18 is equal to 2p, that's x over x, and 6x plus 36 is equal to, oh, this is not 12, this is not 18, it's supposed to be 12 here. So this answer is wrong. Okay, so the answer is really 6. Okay, well, it's supposed to be 12. And then you got 12x. You got x is equal to 6. Okay, so my given answer was at an error. Let's get on to the next problem, which is problem number 15. What does problem 15 say? So here you see you have a geometry problem. All right, the triangle ABC, there's A, B, and C. It's inscribed in a circle with center O. So there's a circle, the center is O, and you got triangle ABC. The perpendicular bisectors of the sides. Okay, the three sides. If you draw a perpendicular bisector, perpendicular bisector means it's a line which bisects us. Like for instance, one of the sides of the triangle is AC. So you take the midpoint of that. There's a midpoint here. And you draw a perpendicular, and that line is called perpendicular bisector. So each side, the side here, take the midpoint, draw perpendicular, and take the midpoint, draw perpendicular. Interesting fact is that all these perpendicular vectors, they all meet at the same point. They are concurrent, as you can see here. Not only that, this point here where they meet is the center of the circle. It's the center of a circle. If you put the compass point here and take this as a radius, well, actually, take this as a radius, the circle will go through A, B, and C. So this is the way you draw the circumscribed. You call it the circumscribed circle of a given triangle. You take the perpendicular bisectors, you see where they meet, and with that as center, you draw a circle, and the circle will go through all the 3 points. But in this case, you've got another circle, which is where the perpendicular bisectors, where they hit the circle, right? That gives you another triangle. All right, and the question is, what is the size of angle DEF? Like this one here. What is the size of DEF? DEF in degrees. Okay. Now, a very important theorem in circle geometry is the following. If you take any circle and you take a chord is a line that joins 2 points in the circumference, a line segment. So you take a chord, so that's a chord. Now, if you take a point on the circumference, take any point on the circumference, take this point here, for instance. Take a point like that, and then you join that point to the 2 end points of the chord. Actually, I'm going to start from one end point and go up to this point, and then from here, I'll come down to the other point, the other end of the chord. You get an angle formed. This angle is given a name. It is said to be the angle subtended look at this angle here. It's the angle subtended, subtended, by the chord AB. Sorry, the writing is very bad because I can't seem to operate this pen comfortably. Sorry about this. Subtended by AB at the circumference, because I took that point, third point on the circumference. Okay. Now, there's also a center for the circle, and you could do the same thing and try to find out what is the angle subtended by AB at the center. So the way to do that is start from one end, go up to the center now, and then from there, you join it to the other end of the chord. So this is the angle subtended at the center. I'm not going to rewrite this because the writing is very bad. So this angle here, let's call it O. If I call the center O, as you can see in the diagram, center is also called O. Generally, that's a symbol that is used for the center of a circle. This angle here, AOB, is the angle subtended by the chord AB at O, at the center. Now, interestingly, this angle here is always twice this angle. The angle subtended by the chord at the center is twice the angle here. That's a theorem in geometry. Okay. You could, if you want to prove it, all you have to do is to join these 2 points, the point, the point of the circumference and the center, join it, but extend it a little bit. And then what happens is that I got 2 triangles, and these are radii from O to the center, from O to the circumference, O to the circumference. So these 2 lines here are actually radii, and you have, that becomes an isosceles triangle. In fact, there are 2 isosceles triangles in the picture. Okay, and for an isosceles triangle, these are all radii. The angles are the same. If I call this dot, right, and the angles opposite these equal angles, equal sides are equal. So you got dot dot and you got cross cross. But now by the exterior angle theorem, this angle here is double dot, because in this left-hand triangle, you take one side and you extend it. This plus this is exterior angle, and this plus this is double cross, because you got cross cross and this exterior angle. So you see the angle at the center is 2 dots and 2 crosses, while the angle at the circumference is 1 dot and 1 cross. That is why this angle here is twice the angle at the circumference. So this always happens. Okay? All right. So in this diagram here, this question mark, right? If this is x, we need to get this. You can see if you look at the chord DF, it subtends the angle DEF at the circumference, and we just said that this angle, if this angle is x, the angle that the same chord DF subtends at the center is DOF, right? So therefore DOF is twice. So this is 2x. Right? But now you will see that this angle here, 2x, is an angle in this quadrilateral here, whose vertices I'm pointing to. And in that quadrilateral, two of the angles are 90 degrees. Right? So those two add up to 180. But in any quadrilateral, all the four angles add up to 360. So if these two add up to 180, then these two will have to add up to 160 also. So in other words, 2x plus 70, those are the angles, two remaining angles. 70 plus this angle 2x is 180. So you have an equation involving x. You solve for it, you get x as 2x is 110, so x is 55 degrees. So that's the answer to the question, which is angle DEF. We named DEF as x. All right, so that was the question. So let's get on to the next question. We know so here is the answer to the question. All right, and if you didn't understand it very well, you can check it out. You'll see it's 55 degrees. What is the remainder if n squared is divided by 8, where n is equal to some monstrosity of a number? It's got 5, 6, 5, 6, 5, 6. 4, 5, 6s. 5 of them, I think. And a 3. All right. Now, interestingly, when you take a number, integer, and you square it and divide by 8, let's just try a few. 1, 2, 3. Let's call this n. 4, 5, 6, 7. Right? And when you calculate n squared, you get 1, 2 times 2 is 4, 3 times 3 is 9, 16, 25, 36, 49. Now you divide by 8. Divide n squared by 8, n squared, and write down the remainder. All right, when you divide 1 by 8, the remainder is 1. When you divide 4 by 8, the remainder is 4, is 0 times. 8 goes into 9 one time, but the remainder is 1. You're only interested in the remainder. 8 goes into 16 two times, the remainder is 0. And here 25, 8 times 3 is 24, the remainder is 1. Here the remainder is 4, and here the remainder is 1. You'll notice that the ones keep coming up whenever your number itself, well, let's start with this. The number 1, 3, 5, 7. For those numbers, the square has the property that when you divide the numbers by 8, the remainder is 1. So when you have an odd number and divide it by 8, the remainder is always 1. If you square it. Right? Okay, you can see it in this 4, but in general, if you take any odd number, it has the form 2k plus 1. Right? An odd number is always an even number plus 1. So if I take any odd number, if I square it, now that's 4k squared plus 4k plus 1. And that is the square of a binomial. And this part here is 4k squared plus 4k. I can take the 4k out as a common factor. And I have 4k into k plus 1, 4k, this is plus 4k comes out as a common factor into k plus 1. And here, this is the product of two consecutive numbers, k and k plus 1. Whenever you have two integers which are next to each other, right, they are consecutive, one of them has to be even. Right? So now you have 4 times an even number plus 1. But 4 times an even number is, this is 2. The even number is 2 times something. So you have 4 times 2 times something. So you can call it 8q plus 1. So if you square any odd number, right, it is of the form 8q plus 1. In other words, it is a multiple of 8 plus 1. That tells you that the remainder is 1. So it's a multiple of 8 plus 1. So this is a proof that the square of every odd number, the remainder is 1. So if you use that as a fact, right, um, then this problem here becomes right. So you have the recording. The recording. Sorry about this. So you have now here you see n is an odd number, and if you square it and divide by 8, the answer is 1. Straight away we can make use of this fact here. I'll give you a general fact. If you take any odd number, you square it and divide by 8, the answer is 1. Okay, so let's get on to the next problem. Here I use an useful fact, which you can use at other times. Okay, so I've actually proved it for you here in a different way. So you can have a look at that. If you did not know this fact, you can still prove this. All right. So let's get on to the next problem, which is now problem number 17. Problem 17 says the following. Brian builds a rectangular patio with 6 square wooden sections of side lengths 1, 1, 2. Okay, you got 6. So they are square wooden sections, and you are making, oh, sorry, you are creating a patio, some kind of a thing, and you take these 6 of them, they've got different sizes, right? 2 by 2, 1 by 1, 3 by 3, and so on. You patch them together to make a rectangle. Okay, now these are the sides. Now the question is, how do you patch them together? And now here's a fact. Now this thing here, this numbers here, they are not random numbers. You may be aware of something called the Fibonacci numbers, the Fibonacci sequence. And the Fibonacci sequence has got the property that it starts with 1 and 1, and then after that, each new number is the sum of the two. So 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8. The next number will be 5 plus 8, which is 13, and then you'll have 8 plus 13 is 21, and so on. So you can build up this entire sequence using only those numbers, right? Now, it turns out that when you got a Fibonacci sequence, you can actually make a rectangular thing with all squares inside it. So I'll show you how it's done. If we look at So I've drawn something here. I've actually drawn something which is 8 by 13. Uh, and if you remember, the last number in the sequence was 8. Let me just get the numbers again. The squares are 1, 1, 2, 1 plus 2, 2 plus 3, 3 plus 5. And then I said that 5 plus 8 is 13. And I've actually drawn a 13. This is 13 by 8. And you'll see how I can patch these things together. Right? Now watch. First, you drop an 8 by 8. So this is 8 by 8 is this one. Okay, if you look this way, you see 8. And if you look downwards, you get 8. So this is 8 by 8. And then you do, now you go to make a 5 by 5. This is finished. You got 5. 5 is remaining here. So let's cut off a 5 here. So from 8, I drop off. From 13, I drop off 8. I must get to 5 because we said 5 plus 8 is 13. Right, from this 8 by 5, I knock off the 5, and I'll end up with 3 here. Right? And then you draw a 3 by 3 square. So you cut off the 3, and then you take the 2 by 2 square, and then you take a 1 by 1 square. It's magic. Right? You can actually create a rectangle using the Fibonacci numbers. So this is 8 by 8, that's a square, 5 by 5, 3 by 3, 2 by 2, and of course this is 1 by 1. Okay. So the question is, what is the perimeter of this rectangle? Well, as you can see, the rectangle, the length is 13, the breadth is 8. So the perimeter of a rectangle is 2 into length plus breadth. So that is equal to 2 into 13 plus 8. And 13 plus 8 is 21 times 2 is 42. So the answer to this question is which we didn't look at nicely. Let's just have a look at that. What is the perimeter of the patio if it is completely covered with the wooden sections with no overlapping? And that's what I've done. And we saw that the perimeter is 42. So there's the picture. We go on to problem number 18. They say here, let fx be a linear function. Now, a linear function is any function of the form f of x, y equals mx plus c. That's called a linear function. It's called a linear function because when you draw its graph, it's a line, straight line. And linear is the adjective from the word line. So whenever you draw a graph of something like this, it's a straight line. And of course, if you had a quadratic, ax squared plus bx plus c, then the graph of that is the parabola, and so on. Okay, so you got a linear function. We don't know what m is, what c is. But it's given that f of 6, the f of 6 is, if you substitute 6 for x, you have m times 6, which is 6m plus c. And f of 12, oh no, I'm sorry, f of 2 is mentioned here. So let's look at f of 2. When x equals 2, you got 2m plus c. Right? So you are given that f of 6 minus f of 2. So this is f of 6 minus f of 2. The c's cancel. 6m minus 2m is 4m. But it's given that this is 12. F of 6 minus f of 2 is 12. So 4m is equal to 12. So that gives you m equals 3. Okay. So now the question is, what is f of 12 minus f of 2? Okay. So f of 12, again, is 12m. F of 2 we saw was 2m plus c. So f of 12 minus f of 2, to subtract these two, c minus c is cancelled, and 12 minus 2 is 10. So you get 10m, but we saw that m is equal to 3, so this is 30. So that's the answer. The answer to this question is 30, problem number 18. But I don't think that was very difficult. It's just the thing is, you must understand this notation for a function. F of x is mx plus c. You can substitute any number. You must put that same number inside here, the same x. All right. So we said that the answer to this question is 30. And if you, as you can see, I have shown that this is indeed 30. All right, so let's get to the next question. Problem number 19. A sweet factory produces chocolate and caramel sweets. The chocolate sweets are produced by a machine at the rate of 3 per minute. So let's just look at this machine. So you got a chocolate producing machine, and you got a caramel producing machine. Choc, this is caramel. And this thing produces 3 per minute. So you got 3 chocolates per minute. All right, chocs per minute. So in 1 minute, this machine produces 3 chocolates. And here, the caramel sweets are produced by a different machine at the rate of 4 a minute. And these two operations are, these two machines, rather, were in operation for a combined time of 18 hours. So now it's moved to hours. Okay. So we can see 3 chocs per minute. Let's convert that to hours. In 1 minute, it's 3 chocolates. So in 1 hour, it's 180 per hour. In 1 minute, it produces 3 chocolates. So it's 60 minutes in an hour. So 60. And here, this thing is 240 caramels per hour. Okay, so in 1 hour, this produces 580, and this thing produces 240. Now, it says here that these machines are in operation for a combined time of 18 hours. But they don't tell you to produce a total number of 3,600 sweets. For how many of these 18 hours was the chocolate machine in use? So the question is now, this chocolate making machine, we don't know for how many hours it was being used. So let's just say it was used for X hours. And altogether, combined time of 18 hours. So the other machine would have been used for 18 minus X hours. So the chocolate machine was used for X hours. In 1 hour, it produced 180 chocolates per hour. So in X hours, the number of chocolates which was produced by the chocolate producing machine is 180 times X, which is 180X. And likewise, this is 18 minus X, because there were 18 hours altogether. So this machine produces 240 in each hour. So in 18 minus X hours, it produced that number of chocolates. So altogether, the total number of, this caramel, the total number of sweets that was produced is that number of chocolates plus the number of sweets. So it says here, 3,600 sweets. That's the total number of sweets were produced altogether. And the question is, we call this X. We need to find X here. You've got a single equation. Okay, I can cancel. I can see 60 goes into this. The 60 times 3. I'll come back to my minutes thing. And this is 60 times 4. And this is 60 times 60. So if I divide right through it by 60, I get that. And I think you can go on and see that X is actually equal to 12. Okay, 12 times 3 is 36. And this is 4 times 6 is 24. And 36 plus 24 is 60. You can calculate this. It's a simple equation. Okay, so the answer to that question is 12 hours. Okay, that's problem number 19. Now let's just go down to problem number 20. But first, let me check to see. All right, so I show you this picture so that in case you did not understand my words, you can see there's a detailed explanation for that. Okay. Now let's just do one problem number 20. So 20 is a problem in geometry, it seems. So what do you see here? I see a circle which is sitting inside a quadrilateral. To draw this, you draw a circle, draw a tangent here, another tangent there, another tangent. So these four sides are tangent to the circle, right? And it's given that WZ is parallel to XY. So let's just see, there's WZ is parallel. So these two lines are parallel. So the whole figure is a parallelogram. You also got that WX is equal to ZY. This WX is equal to ZY. Okay. And WZ is 18. So this line there is 18. And XY at the bottom is 32. This entire line is 32. So you're given that this is 18, this is 32, these two are equal, and you've got a circle which is inside this. And the question is, what is the length of the diameter of the circle? Okay, so I'm going to draw a diameter like this. This is a point that if I take the center of the circle, and join it to this point, we take the center of the circle and join it to this point, it's going to be 90 degrees. And from the center, if I join it to this point, that's also going to be 90 degrees. So you can see if I join these two, those 2 points, it must go through the center. Because this is a tangent is perpendicular to the chord or to the radius at the center, drawn from the center. So we know that if this is your center O, then this is 90 degrees, 90 degrees. So when you join these two, you must go through the center. The perpendicular from here goes to the center, perpendicular from here goes to the center. So these two perpendicular lines are exactly the same. All right, so I've drawn that, and that is your diameter. So the question is, what is this length here? All right. Now, to do that, to find out what this length is, what I'm going to do is I'm actually going to draw from this point here. Let me draw another line perpendicular, another line perpendicular. I'll draw these two perpendicular lines, and so now I have these two lines are parallel because they're both 90 degrees, yeah? They're both are perpendicular to the same line. So all these three lines are parallel. The co-interior angles, if you like, are supplementary. So therefore, all these lines are parallel. Okay. So we need to work out all, so these are rectangles. These two are rectangles. So this diameter is the same as the red line. So I need to calculate this red line here. Okay. Now, here's something. These two are actually equal. Those two lengths are going to be equal. By symmetry. You see, this whole thing is because these two are equal. Let's put it this way. If you look at these two triangles, let me just color these triangles. Look at this triangle here, and this triangle on the edges. Those two triangles, we are given that these two sides are the same. We are told by construction these are 90 degrees, and these are equal because you've got a rectangle. Opposite sides of a rectangle are equal. So these two triangles are actually congruent, which means that this line here is the same as this line. Now, this entire line here is 18. So it means that the entire line is 18. So in this rectangle, this has to be 18 here. The opposite sides of a rectangle are the same. And we know that the entire line is 32. It's given that xy is 32. And we just saw that these two have to be the same because they are sides of two congruent triangles. So these two triangles, blue triangles, are identical in every respect. So this will be the same. And the entire line is 32. So these two add up to 14. So each one will have to be 7. See, each one will have to be 7. Now, so this is where we are. Now, I don't know this length here. It's Wx. Okay. If I know that, then let's call this y. Let Wx be equal to y. Then if I know that, then I can use Pythagoras to actually calculate your diameter. Then the diameter is equal to the square root of, it's this red line. So it's the square root of y squared minus 7 squared. Because this triangle here, the right angle triangle, has got side 7, y, and this. So now I need to know what is this side equal to Wx. All right, now I'm just going to digress a little bit. I'm going to rub out all these lines because go back to my original picture. And I'm going to observe something. You see, if you got two tangents from the same point, so this is another theorem in geometry. If you got a circle, and if you take any point outside the circle, outside, then you can draw two tangents. One like that, another one like that. And an interesting result is that these two tangents have got the same length. From every point outside, you can draw two tangents, and those two tangents will always have the same length. If you want to know why, I'll take this point of contact, join to the center, and this point of contact, join to the center, and then join these two. And if you look at these two triangles that have been formed, you will see that they are congruent. Right? You'll see that they are congruent because these are radii, you see. So they are equal, and these tangents are perpendicular, or the radius is perpendicular to the tangent. So, and this is a common side. So these two triangles are congruent, which will make these black lines equal in length. Right? Those are the two tangents which we have drawn. So here you can apply that result 4 times because there are 4 pairs of such tangents. Right? I'm going to give names to them. At this side here, let's call this point A. That's also A. But these are tangents, 2 tangents from the same point outside. If I call this B, this is also B. If I call this C, this is also C. And here you got D, D. So you got 2 tangents are equal. And this is a point of contact here. So this whole thing is C. Okay, and now you'll observe something very, very, very interesting. Namely, that the sum of the opposite sides okay, we had that this is 18. So A plus B plus C plus D is 18. Let's do it like that. So A plus B plus C plus D is 18 plus 32. Because you got 18 here, and B plus C is 32. So that is 50. But if you look here, you got this is A plus B plus C plus D. Again, so A plus B plus C plus D is 50 if you rewrite it like that. But A plus B is equal to C plus D. It's given that this line is equal to this line. So these are two equal numbers. So A plus B must be 25. So this line here, WX, which is A plus B, that's your Y. That's 25. A plus B, that's your Y. And originally I named this Y, you see, this entire line. So that is 25. So therefore you got your diameter. Because the diameter so your Y is 25, so square root of 25 squared minus 7 squared. There's no need to use your calculator here, because this is the difference of two squares. So it's 25 minus 7 into 25 plus 7. You don't need to calculate to work out 25 minus 7. That's 18. And 25 plus 7 is 32. So if you absorb this 2 here, this is 9 times 2, and this is 9, 2 times 32 is 64. So the square root of 9 times 64, well, that's immediate, you can answer. That's 3 times 8. That's 24. So the diameter is actually 24. I've done it here to show you how you can do it without using a calculator, using some nice algebra, difference of two squares. It's got a good application. And the answer to this problem is 24. That's the diameter. So just check. All right, after some time here, you can see right at the end that the diameter is actually 24.